Wow. Welcome to our last three or four videos that kind of accumulate or culminate the unit of trigonometry. We're going to look at the big picture where we take a look at all the elements that are required to figure out a problem that involves trig. So if you take a look at the picture here, it says that Joe needs to get to the top of a 25-foot wall. The safe angle to place the ladder is at 35 degrees. How far from the wall should he place the bottom of the ladder? And what length should the ladder be that he's going to use? Well, we need to find a couple things. So this is where you're kind of familiar or what you're most comfortable with works. We know we need to find C, and we also need to find, we're going to say A, okay? So we know eventually we're going to use the formula of A squared plus B squared equals C squared. So we can work with that one. If we're going to work with that one, we say, okay, well, we need to know A squared. Well, which one of my trig ratios uses the opposite and the adjacent sides of a triangle to figure it out? Well, if we look at the acronym SO, CA, TOA, we know that tangent is the only one that works with opposite and adjacent because it doesn't even use the hypotenuse. So we set it up that the tangent equals the opposite over the adjacent. We plug in what we know. The tangent of 35 degrees equals the opposite side over the adjacent. Now, if you remember from our previous videos and our previous assignments, these two can switch spots if we need them to figure out the answer. So the answer would then look like the adjacent equals 25 divided by the tan of 35. Well, if we punch that into our calculator, and luckily I have the calculator that we agreed upon to already use. Now, hopefully you can see that. Oh, it's decided to go back to where it was. So scientific. So to calculate that, we need 25 divided by the tangent of 35 degrees. And it says that we need to have it at 35.7 meters. So this means this equals 37.5. We're going to round it up, okay, because that's kind of easier to do. And we're going to say that's 35.7 to 36 meters. Okay. Now we figured out that if we got a 25-meter wall, we need it at 35 degrees. This is how far this is actually going to have to be. Well, we need to know the length of the ladder to actually calculate the final piece. So that's easy. We know that this was B. Okay. We already calculated that the adjacent side was going to be A. So we got to find C squared. So that's using Pythagoras' theorem. And basically we just plug it in. We knew this was A. So 36 squared plus B, which is 25 squared, equals C squared. Well, this is like saying 36 times 36. So we clear it. So we get 1,296 plus 25 squared. I believe that's supposed to be 625. It is. Equals C squared. Now we add the two together. Okay. Once we've added them together, we should get 1921, which equals C squared. Remember, we've got to reduce that by finding the square root. The square root of that is going to be 44 degrees when you punch it into your calculator. And then now we know all the answers that for this question, the ladder is going to be placed at 36 meters from the bottom, and the ladder has to be 44 meters in length. If you have any questions, please get a hold of me. I'll post the next video into explaining another way that we're going to figure out another problem. Hopefully this helps.